Okay, so let's finish up 9.2. This next bit is actually really important for algebra and for us to be able to actually figure out the measure of our angles inside of our triangle. So the angle sum of the triangle states that the sum of the interior angles, so those are the inside angles, will always add up to 180 degrees. Always. That's the definition. If you don't add up to 180 degrees on the inside, then you're not a triangle. Plain and simple. And so what this will allow us to do is they can give you a triangle and they can label various angles within that and then ask you to figure out what the measure of the angles are. And if you don't know that they are supposed to add up to 180 degrees, then you're going to be completely lost. But this angle down here plus this angle up here plus this angle down here have to add up to 180. So if I'm trying to figure out the measure of these angles, I'm going to take x, which is the bottom left. I'm going to add to that x plus 20, which is the top angle. And then I'm going to add to that the 210 minus 3x and set all of that equal to 180 degrees. When I solve this, I will be finding x. Then I will have to go back and plug that into my various angles to figure out what the degree measures actually are. So I have 2 x's minus 3 x's will give me a negative x. I have 220 plus 210. That will give me 230. And all of that equals 180. Subtract the 230 over, and I have negative x equals negative 50, so x equals 50. Well, that is the measure of this bottom angle down here. That's 50 degrees because that one was just an x. Up here, it would be 50 plus 20, giving me 70 degrees in the top one. And then in the bottom right, I have 210 minus 3 times 50. That's 210 minus 150, which gives me 60 degrees. And I can check my answers to make sure I got the correct answers by taking 50 plus 70 plus 60, and that had better add up to 180 degrees. If it does not, then either my x was incorrect to get started with, or I messed up some algebra whenever I was actually finding the measures by plugging them in. So interior angles of a triangle have to add up to 180 degrees. I know you have some homework problems like this, where they will give you some of the information, you have to figure out the rest. Questions? All right. Exterior angles don't work quite that way, but there is a neat little truth that we do know about them. The measure of the exterior angle of a triangle is equal to the sum of the measures of the two opposite interior angles. And you're like, what in the world does that mean? Well, they've labeled your exterior angles for you. So this first one over here is the measure of angle 6. So the measure of angle 6, which is this one, is going to be the same thing as the measure of angle 1 plus the measure of angle 2. The interior opposite angles. If I add these two up, that's going to be the same thing as the measure of angle 6. So who wants to take a stab at what the measure of angle 5 is going to be? If 5 is this one out here, and you may have to turn your paper to reorient yourself. What interior angles lie opposite of 5? 1 and 3. The easiest way to know is it's going to be the one not right next to it. All the other angles, not the one right next to it. So measure of angle 1 plus the measure of angle 3. Last but not least, the measure of angle 4 then is going to do what? 2 and 3. That's exactly right. The reason why this works is because of the interior angle sum. The sum of our interiors have to be 180. Well, if I look at angle 6 and angle 3 are supplementary. They have to add up to 180. And so that's why this ends up working. So that's a nice little cheat to help you, because there are going to be times where we don't have enough of the pieces. And I guess I didn't put the picture for this one. So let me draw you the picture for this one. This is a good example of paying attention to where the angles are whenever you're looking at your problem. Here's A, B, C, and out here we'll put the point D. This is X. This one is X plus 20. And then this one is 3X minus 40. I give an example just like this in my trigonometry class, because we spend the first part of trig doing geometry. This one, though, if you're not careful, you'll think, oh, that 3x minus 40 is for this inside angle of C. That's not where they put that. Notice that, and I'll go back, but look, when we have the inside angles, they put the measure inside. If they have to put the measure outside for space, they will always draw an arrow inside showing you which angle it's representing. This designation is on the outside angle, the exterior angle of BCD. And so we need to find all the interior angles and the exterior angle of BCD. So based on what we just talked about with our exterior angles, how am I going to go about solving this? That's right. Angles A and B are going to add up to give me angle C out here, this exterior one. And so I can add these two and set it equal to this 3x minus 40, so I can solve for my x. And then I'll be able to plug everything in to find the remaining pieces. So I'm going to have x plus 20. Those are my two interior angles. And I'm going to set that equal to my opposite exterior angle and solve. So 2x plus 20 equals 3x minus 40. I'm going to try and keep my x's positive, so I'm going to subtract my 2x over, add the 40 over, so that I find that x is 60. And what we need to know is we need to know all of my interiors and this exterior. So angle A is going to be 60 degrees because that's x degrees. And we just found x is 60. B is 60 plus 20. That's 80. So now you could plug 60 in here, or you can remember A plus B has to give me this exterior angle. 60 plus 80 gives me 140. You can find the exact same value by taking 3 times 60, which is 180. Take away 40, still gives you 140. So what does that make the interior angle of C? 40. How do you know? That's right. These two angles right here are supplementary. So when I add them together, they have to equal 180, meaning this last remaining one would be 40 degrees. Great job. Are there any questions on these? Obviously, you have to do a little bit of algebra, but it's basic equations. Nothing too crazy. All right, we're going to switch just a little bit to circles. Oh, we do have a problem with circles. Good. I gave you one. The reason why we talk about circles right after we talk about triangles is because we use angles and measurements like that to measure circles as well. So a circle is a set of all points in a plane that are equidistant from a fixed point known as the center. So equidistant means the same distance from. And so when you have a center, the circle is comprised of all these points that are the exact same distance away from that center. And this whole page is just a really good reference. I really liked this table because it condensed every terminology you could ever want to know about a circle all into one nice spot. It has nice pictures to go along with it, and so that's why I went ahead and just made a nice table. Now, do you have to memorize all these things? No. On your test, you remember you will always get a note card, so you can kind of give yourself some little cheats or hints and things like that. And if I remember correctly, there was a total of 2 circle problems, I think, on the homework. So there's not a lot. That's why I'm going to go through it kind of fast. The center is the middle point. That's very important. The radius is going from the center to the outside of the circle. So you start at the center and you touch the circle. That distance is known as your radius. And there's a couple different radii given here. The diameter, I'm skipping the chord for a minute. The diameter is where you go all the way across your circle, but you go through your center. That's a big thing. Diameter is double the radius. So 2r is your diameter, if you want to write that down. A chord is a segment with both endpoints lying on a circle. So the chord in this picture is P and M. This is a line segment that runs through the circle, but does not go through the center. If you're a line segment that goes through the center, then you're a diameter. An arc of the circle consists of 2 endpoints on the circle and all the points between those. So an arc would be in P. It's this outer ring. That's an arc. It's like the crust of a pizza. That's an arc. A semicircle is like the bottom half. General shape is a semicircle. Then we have minor arcs and major arcs. That's great information. You won't have to know that. So that's just extra. The big thing to know about circle is the center, to know the difference between a diameter and a radius. Because if you ever have to find circumference or area of a circle or anything like that, those are the pieces of information you have to use. Below that in our table are some really good definitions of different types of lines and how they touch or intersect your circles. If you have a line that is tangent to your circle, then it intersects the circle at only one point, and that point is called the tangency. So that's this outer one. Tangent lines are really important, and actually we use this terminology in everyday speak, where you may be in a lecture and your history professor is talking to you about the history of France and blah, blah, blah. And then they go off on a tangent talking about macaroni. Don't know how, it just randomly comes up. There's one tie-in where it's like, oh, we were talking about this and now we're going to go over here for a minute. That's a tangent. It has one point of commonality, so that's a tangent line. A secant line will have 2 points in commonality. And then you will have inscribed angles. An inscribed angle is like PQM. That's where you have these 2 lines that make a big angle from the other side of your line. There's another problem on the other side about inscribed angles. And then we have the intercepted arc, which is PM. That's over here. It's the arc that lies within your inscribed angle. Lots of good terminology. This is a really good reference page is what I'm going to say about it. If you want to continue on and take college algebra and go on to trig, lots and lots and lots of stuff to do with these. The one problem that I noticed for sure is in your homework is very similar to this, where you are asked to identify all the different pieces of a given circle. You're asked to find the radius, the chord, the arc, the tangent line, the secant line, and the inscribed angle. So I know I just took all of that information away from you because it's on the other side. So let me turn mine off. All right, radius is the first thing that we need to find. The radius runs from the center to the outside edge of your circle. So what line segment would be my radius? OP works. Yep. There's multiple because OP would be one, OR could be one, even OQ could be one. Because all of those start at the radius and they go out into the outside circle. So any of those would work. Remember, with a line segment, you put a line over the top, and then you said OP, so I'll write that one down. If I remember correctly, I think these might be multiple choice on Pearson. So a chord is a segment with both endpoints lying on a circle but does not go through your center. So we need a line segment that goes from outside of the circle to outside of the circle but doesn't go through the center. So PR would not work because that goes through my center. PQ would work. All right, C is an arc. PQ again, only this time we would have the arc symbol above it. Because PQ here is a line segment, but when we say arc with the arc symbol above it, we're talking about this outer ring. We're talking about that crust of our pizza. Okay, D is a tangent line. It touches in exactly one spot on our circle, and that is it. Line RT. Notice it just touches right here at the point R. Only has one shared point. A secant line is going to have two shared points. PQ. And last but not least, we have our inscribed angle. This is where it's going to go all the way from one side of the wall to the other. POQ. So that would be this angle. But an inscribed angle goes all the way. PQ. Well, there's not PQ, but there's not a thing connecting Q and R. Can't have O because that's the center. What about R, P, Q? Can we see that? Where the inscribed angle would be this one. So angle R, P, Q, or you could say Q, P, R, whichever one. It still describes the same one. We need an angle that touches from one side that has the two lines going all the way through to the other side. The last note about inscribed angles is simply that any angle inscribed in a circle has a degree of half the measure of its intercepted arc. So if we know what the inscribed measure is down here, we can double that to figure out the degree measure of our arc up top, or vice versa. If we know the degree measure up here, we could cut it in half to know our inscribed circle measure down here, or our inscribed angle measure. So there's not a problem for that one. It's just a neat piece of information. It's a nice connection to know.